Okay, so today we are going to be discussing logarithm topic. Okay, so to start things off, I'm just going to introduce logarithms as a different perspective to look at exponential function. So this is not a proper definition and perhaps it is also kind of vague, but let's just look at an example to see what I mean. So since we just practiced on a lot of exponential functions last week, I'm going to give you a very simple exponential expression of, let's say, 2 to the power of 5. Okay, so we know the answer to this is 32, right? But what if I want you to tell me what is the process of this expression means? Yeah, so it's kind of like we have 2 to the power of 5 is like an abbreviation of 2 multiplied to itself for 5 times, right? This is 5. 1, 2, 3, 4, 5. Great. We have 5 multiples of 2 here. So what we did is kind of like we shortened the process that requires 5 steps into 1. Alright, and if we look at this breakdown of this process, we see that our number is growing in multiples of 2 each step of this process, right? So here we can have 2, 4, 8, 16, and then only 32. It's like doubling every step we go. And so if we were to look at this expression, the base 2 in this expression is kind of like our growth rate in the sense that it is growing in multiples of 2 per step, right? And 5 is how many steps or how many times that we allow this number to grow. And then we get 32, which is our result. Basically meaning to say the number has grown up 5 times to become 32. So let's look at in another example of, let's say, 2 to the power of 0. And we know the index law of this will give us the answer of 1. Okay, now think about what we have just discussed and apply it here. My growth rate is 2, meaning to say that the number is growing in multiples of 2 per step. But in this case, it has grown 0 times, right? So what that means is our number hasn't grown at all. It is the same size at where it started. Okay, so now I'm going to write down some logarithm expressions and then we can figure out what perspectives are we looking at the exponential functions from. So I'll give you log 32 base 2 equals to 5. Okay, so if you were to look at them in comparison, so here we have 2 to the power of 5 equals to 32. You kind of just see like I'm just shuffling around the numbers, right? Okay, now we recall again. What is 2? 2 is our growth rate. And 32 is our result. Meaning to say, if I am growing this much per step, and this is how big I ended up, this is how many steps I have taken. Okay, I'm going to say that again. If you know how much you are growing by, and you know how big you end up, you can find out how many times you have grown. Okay, so let's look at another example.